Hello, welcome to the ballistic pendulum lab. What we have here is a way to measure the velocity of a projectile. So we can think of this little ball here as being a bullet, because they actually use this kind of thing to measure the speed of bullets. And that is going to get shot into the pendulum. So this cylindrical device has a little rubber ring in there that's going to catch the ball. So it's going to be an inelastic collision. The ball is going to stick in the cylinder, and that pendulum is going to swing upwards. And the higher upwards it swings, the faster that ball/bullet was going. But there are two methods we're going to use to calculate the initial velocity of this ball today. And one involves just shooting it and seeing how far it goes. So we're going to remove the pendulum to do that. Here, our lovely assistant Jason will show us how to measure how high the ball is starting from. So Jason is holding this ruler here. I'm going to get down right on level and see that the middle of that ball, or actually we'd have to use the bottom of the ball, right? Because the bottom of the ball is going to hit the ground. So it's right about 88.5 centimeters, or 98.5 centimeters above the ground, because the ruler is on the ground, it's pointing straight up. So that is the vertical distance the ball will travel when we shoot it and just let it go there and hopefully hit Jacob, maybe in the foot. Jason is pointing out that when we fire this, we're going to want to know exactly how far that ball traveled horizontally, and so maybe it'll land about here on the floor. But that distance it traveled isn't just going to be the distance from here on the floor to the bottom of the table. We're going to also have to add, how much, Jason?
27 centimeters.
27 centimeters, because that's how far from the ball when it's released to the edge of the table here. Lovely assistant Michelle has volunteered to fire the ballistic pendulum without the pendulum there, and see how far this ball travels. So we got a napkin out there for reference. Let's see how this works. Did that hit the napkin?
Hit the napkin.
The far side?
Yeah.
Amazing. Any good experiment should have some repetitions involved, and we should come up with an average of the data. So we've put a more precise target out there where the napkin was, and Michelle's going to fire again. Just a little bit past it.
Right here.
I think it went a little bit past it.
I should nail it.
Loaded for a third time, and I think we're ready.
It's persistent with the distance.
We're going to take a different perspective here. I'm going to get down for a close-up. All right, ready, Michelle? That was just a blur. And Jason is going to measure the distance from the table to the average of those ball impact points on the floor. So that's a meter.
Pin or something?
So it's 2 meters and 48 centimeters.
Yes.
All right, so that was from the table.
Yeah, plus the 27.
2.48 meters, yes, plus that 27 from the ball to the edge of the table. Jason is showing us the center of mass of the pendulum plus ball. The ball is actually in there. We want to know where that center of mass is, because when we fire the ball into the pendulum and see how high it goes up, what we want to see how high it's going up is the center of mass. So it looks like the center of mass is just about at that little black mark. If you're interested to know the difference in height between where it starts which looks to be 8.2-ish centimeters, and where it ends up, which will be higher. So whatever goes above 8.2 is our change in height. At the moment we've been waiting for, Jason is actually going to fire the ballistic pendulum. Let's try that again. Alright, attempt number 2. Attempt number 3, we've made sure it's all lined up. There's no...
Off to the side. Okay, looks better.
Hey! Success. So now we just have to measure the final height of that center of mass, that little black point. And we're looking in inches here. Can you flip the ruler, please? Beautiful. Alright. Kick the bottom just a little bit to the right. So there it is, let's say about 15 and a half centimeters. Alright. Thank you, Jason.